Okay, let's talk about our solar system. So in this picture here, it shows the sizes of the various planets in our solar system to scale, so that you can notice that the first planet that you come to from the sun is going to be Mercury. And look at how small Mercury is. And then next to it is going to be Venus. You notice that Venus is about the same size as the Earth. And then outside the orbit of the Earth is going to be Mars. And Mars is about 1/2 the diameter of the Earth. And then outside the orbit of Mars is going to be what's referred to as the asteroid belt. And the asteroid belt contains rubble that is left over from the formation of the solar system. Outside the orbit of the asteroid belt is going to be the first of the gas giants, which is going to be Jupiter. And you can see that underneath there is 4 of the largest moons of Jupiter. Now, it actually has many more than just 4, but those are the 4 largest moons of Jupiter. Then outside the orbit of Jupiter is going to be Saturn, and then further out than Saturn is going to be Uranus, and then further out than Uranus is finally going to be Neptune. And then you might be saying, well, what about Pluto? Well, Pluto got demoted. It's not considered to be a planet anymore in the sense that Earth is a planet. So let's all shed a tear for poor Pluto. So Pluto is now considered to be a dwarf planet, and that's because it doesn't have enough mass to generate enough gravity to clear out its orbit of debris. And so it just got demoted from being a planet like the Earth to a dwarf planet. Well, that actually is a pretty good thing, because if you look at that picture there, you notice all of those other things that are around the same size as Pluto. And I, for one, would not want to memorize all of those names of those other objects in our solar system. Okay, now you might be wondering, what about the size of Jupiter? It's not on there. Well, actually it is, because if you look closely at that picture, you might need to blow up the picture so that you can see it, but you'll notice some red lines that are doing this. Well, this line over here, that's the outline of the edge of Jupiter. And then this one here, that's the outline of the edge of Saturn. So that Jupiter is something like 10 times the diameter of the Earth. So it's very, very big. And then if you look over on the left-hand side, you might notice another red line which almost looks like it's straight up and down. Well, it's actually curving, because that's the outline of the edge of the sun. So imagine that the sun was 1.5 meters in diameter. So that's about 4.5 feet. So it's going to be about this big. In comparison to that, the Earth is going to be about the size of a marble. And then in comparison to Earth, Jupiter is going to be about the size of a basketball. So that just gives you a rough idea for how big the planets are in our solar system. So what are some general characteristics of them? So we could divide the solar system up into the inner part, the middle part, and then the outer part. The inner part is where the terrestrial planets such as Mercury, Venus, Earth, and Mars are. Another name for this would be the rocky planets. So they're going to be relatively small. They're going to have a high density. Now we'll talk later about what density means, but they have a high density because they're composed of rock. The composition is they're composed of rock. Then they have few moons. So like, for example, Mercury doesn't have any moons. Earth has 1 moon. Mars has 2 moons. Now compare that to the Jovian planets, such as Jupiter, Saturn, Uranus, and Neptune. So they are relatively large in comparison to the Earth. They have a low density because they're composed of gas. They're composed of hydrogen and helium. So those two elements comprise the gas in the gas giants. And then they also do have ice in them. So they have like methane ice, carbon dioxide ice, and so forth. They have a large number of moons because they're very large planets and they have a lot of gravity. Then you have what we referred to as the dwarf planets, which are outside the orbit of Neptune. They're basically the debris from the formation of the solar system. Just rubble is out there. And they're much smaller than the gas giants, and they are smaller than the terrestrial planets. They have a medium density because they're composed of both rock and ice. Methane ice, nitrogen ice, carbon dioxide ice. And so that means that they have a density less than the density of rock by itself. And they tend to have very few moons in orbit around them. Okay, before I go on, let me say just a little bit more about the individual planets in our solar system. So Mercury is the one that's going to be the closest to the sun. So that means on the side of Mercury that gets the sunlight, it's incredibly hot. On the side that doesn't get the sunlight, it's incredibly cold, even though it's so close to the sun. Mercury is very small. That means that it has cooled off very rapidly. So it's not very hot on the inside of Mercury. It doesn't have much mass, which means it doesn't have much gravity, which means it has a very thin atmosphere. Okay, now let's look at Venus. So Venus is about the same size as the Earth, but it's closer to the sun. So that means it's going to be hotter. And in addition, it has a runaway greenhouse effect, which we'll talk about later in the course. But for right now, all you need to know is it has a very thick atmosphere composed of carbon dioxide, which traps heat. It's so hot on Venus that if you take a brick of lead and you put it on the surface, it would turn into a puddle. So it's very hot on Venus. Okay, now let's go, we're going to skip Earth because that's what we're going to be talking about for the rest of this video series and the rest of this course. So let's go on out to Mars. The number one thing that determined the fate of Mars is it was small. Because it was so small, it lost heat rapidly and it cooled off on the inside. And it also, because it's so small, it has a thin atmosphere, which means it can't trap heat as well as what Venus can. So it's very cold on Mars. Now let's go out and we're going to just lump together Jupiter, Saturn, Uranus, and Neptune. And we're going to say that they're gas giants. They're going to be composed of mainly hydrogen and helium. And then they also do have some ices in them, such as methane and carbon dioxide, so and ammonia. So they also have those gases in their atmospheres as well. But they're very, very large, and they're composed of gas. And then we've already talked about Pluto. So Pluto is going to be composed of rock and ice. Methane ice, nitrogen ice, carbon dioxide ice. It's going to be incredibly cold out there because it's so far from the sun. All right, so let's take a break. And when we come back, we're going to talk about some physics.